work energy theorem. So actually this theorem will help us if you don't know the force and displacement is given. If you have no information how to find the work, then you will use this work energy theorem. Most of the question which is not solved by the W is equal to F dot S, it is being solved by this theorem. It is very, very important theorem. So write down. From the statement also you can understand work energy means work converted to energy. There is a relation between work and energy. So write down. It states that work done by all the forces is equal to change in kinetic energy. Okay.
Okay.
Right on. Next point. Internal force cannot change momentum by heart. These points by heart you should remember. Okay. Internal force cannot change
Okay.
momentum. That's why you are writing in law of conservation of linear momentum. External force we are taking. Okay.
Okay.
There is no change. Net force, net internal force is zero always. Can't change momentum. Okay. Otherwise, you are sitting
Okay.
here, you are flying. If your internal momentum is working now, but right on internal force cannot change momentum, but can change kinetic energy. Okay. After this, right on in non-inertial frame, in non-inertial frame, work by work done by pseudo force is also considered. Okay. All the force means all the forces. Pseudo force, conservative force, non-conservative force, all the force. Meaning is that the work done by all the forces is equal to the change in kinetic energy. Yeah.
Okay.
If you write, just write when you are applying this, write down note. This theorem should be applied where should be applied where acceleration changes. Okay.
Okay.
Changes multiple times or work is required. Work is required when force is not given. Force is not given. Okay.
Sir, I can't understand this thing.
I will tell you. Or without force. What you are not understanding?
Sir, from the starting, sir, this work energy theorem.
I will tell. I will tell now. I didn't explain anything. Meaning is what?
Sir, can you please? Sir, writing, sir.
Hello? Yes?
Sir, I'm writing, sir, one minute, sir.
Right,
I'll
right.
write.
This is just I have written. Till now I didn't explain. Let me finish.
Okay.
Okay.
Okay, sir.
Meaning is that work done by all the forces, work done by all the forces is equal to change in kinetic energy. Meaning is that all the forces means conservative force, non-conservative force, pseudo force, okay, external force.
Okay, sir.
Conservative means internal, external force, external, okay,
Okay,
all
sir.
the forces. Clear?
Okay, sir.
Means
Yes,
like
sir.
that if you want to write work done by external force, work done by pseudo force, work done by conservative force, work done by non-conservative force is equal to change in kinetic energy. Final kinetic energy minus initial.
Physical kinetic energy. Okay.
Clear? Meaning is that. Okay?
Okay, okay, sir.
If W is 0, W there is no work is done by external force. There is no work done by non-conservative force, means there is no friction. No friction. Okay? Okay, there
Okay.
is no pseudo force, inertial frame. Then we can write what? Work done by what we can write? Work done by conservative force is only left now.
Yes, sir.
It will equal to final kinetic energy minus initial. Conservative force, you know what is the definition? Delta U will be minus of work done by conservative force. Conservative force, it may be potential energy, it may be spring energy, okay?
Okay, sir.
Minus means this is U final minus U initial. So minus means U initial minus U final. Meaning is that. So you can write UI plus AEI UF plus final kinetic energy. Okay.
Okay.
So this is what? Potential energy plus kinetic energy. This is mechanical energy. Initial mechanical energy equal final. This is law of conservation of energy. Law of conservation of energy. LOC. And it is valid for already when there is no non-conservative force. Non-conservative force is absent. Okay, non-conservative force is absent. Means friction should not be there. Work done by external force is absent. There is no work is done by the external force. Clear? When frame is
Okay, sir.
inertial frame, then only you can say initial energy equal to final. That is law of conservation of energy. This is what you have learned. Initial means law of energy can neither be created nor be destroyed. Here, then change from one form to another form. This is law of conservation of energy. Okay. But condition is there should
Okay,
not
sir.
be friction. There is no friction. There is no work done by the external force. There is no work done by the Sudoku. Clear? Tomorrow lecture, in the
Okay,
tomorrow
sir.
lecture, I will explain numericals for this chapter. Okay. Today we will finish
Okay,
this
sir.
topic. Maybe tomorrow I will take your class. You have a holiday tomorrow?
Yes, sir. Holiday only.
Yeah, so tomorrow I will take your class in morning. Okay.
Okay,
Maybe
sir.
morning or afternoon I will schedule. Okay.
Okay, sir.
Okay. Thank you, Dinesh. Take care. Bye bye. Understood?
Thank you, sir. Yes,
Yeah.
sir.
So write down the heading energy. Okay. Energy. So whenever I am writing energy means mechanical energy. Okay. Energy means
Okay,
what?
sir.
Mechanical energy. Okay.
Mechanical energy.
Mechanical. If I write what is energy, means mechanical energy.
Okay, sir.
And what is the sum of what is mechanical energy? It is the sum of kinetic energy plus potential energy. Okay.
Potential energy. Okay, sir.
So write down the heading kinetic energy. What is kinetic energy? It is the energy. Write down definition. It is the
Okay,
energy
sir.
associated with associated with the velocity of body. Okay. It is the energy associated with the velocity of body. If any object
Okay,
is
sir.
moving now, having some velocity, it means it has kinetic energy. Meaning is that.
Okay, sir.
Clear? Right, our
Yes,
formula
sir.
is kinetic energy is half mv square. What is m? M is
Mass.
inertial mass. Inertial. Because mass has inertia, so we are saying inertial. Okay.
Okay, sir.
V is the speed.
Velocity.
Velocity magnitude we are putting here. Okay. Because kinetic energy is scalar
Okay,
point. Okay.
okay, sir.
It is valid for, right? This expression valid for point mass. Point mass. Second, body.
Sir, for point masses, there will be no mass, no, sir.
Point mass means like this. Negligible mass.
Yes, sir. Then how can we use this formula, sir?
This formula is valid for point mass particle. Okay. If you want for body, you just
Then,
integrate. Okay.
okay, sir.
Or this is valid for only point mass. Next, it is valid for body in which initial speed initial speed at all points. Body initial speed at all points is same. Meaning is what? Linear motion. There,
Okay, sir.
body is having linear motion, so we can apply. If any object is moving linear motion, translatory we can apply.
Okay.
There, after this, write down potential energy. Next heading is potential energy. potential
Okay.
right down. Write down. It is an energy associated with configuration of particle. Configuration understand? In which configuration means shape, size. Okay. Configuration of
Okay, sir.
particle or arrangements. Okay. Meaning is what? For example, I have written this is two particle system. One particle is this, one particle is this. Clear? And the separation between these
Yes,
two
sir.
particles is R1. Is one configuration. Okay. If you
Okay,
take
sir.
this is next configuration. It is having the mass M1. One more configuration. M1, M2, M. Clear? So energy associated. If I ask you what is the, if I ask or anybody is asking like what is the potential energy of this configuration having separation R1. If I increase the separation R1 to R2, what is the potential energy of this? Can you find U1? Can you find U2? If I ask
Sir,
you,
one
can you
minute.
find? We can't.
Yes, sir.
Clear?
Okay,
Potential energy is not a defined quantity, okay? Because we don't know the history of this particle. U1 we can't find. U1 we can't find because this particle we don't know how it formed, okay? Who formed this particle?
okay, sir.
Some energy is stored in this now. We can't find exactly. We can't find.
Okay,
Okay. But we can find the
okay,
change in potential energy. Delta E. Okay. We can't find U1, we can't find U2 because we don't know the history of the particle, but we can find the delta U. So you can write also. Write down potential energy is not a defined quantity to stop. We can define the change in potential energy change in potential energy for minimum two particles. Or this is very very important. Like a spring block, you are learning a potential energy of a spring. No, it is not a spring.
yes,
It
sir.
is for spring block. At least two particle system must be minimum two particle. Okay, we can define the change in
Okay,
potential energy for minimum
two
two
particles.
particles. Minimum particles. I will explain. To calculate final potential energy final potential energy, we have to assume initial value of potential energy. Initial value of potential. Then only we can find exact potential energy at a particular point. Okay. That if I ask like delta U is from A to B, is like for example 10 Joule. Okay.
Okay.
UB minus UA if I ask. Then UA, if you assume UA is 0, then UB will be 10 Joule. Like this. Meaning is that. If you need to assume exactly if I am saying like we are assuming, but actually we can't assume. For making our calculation easier, we are assuming initial value in order to find the final value. Clear?
Okay, sir.
Now write down the formula of potential energy. Potential energy is defined for conservative force. Previous slide. Right.
Yes, one is.
Write it first.
1 minute, sir.
Right. If you have any doubt, you can ask me. Everything will be clear. Okay. Whatever to the point I am teaching. Okay. Whatever it is. So.
Okay.
Shall I move?
Yes, sir.
So delta U formula, you should write the formula of delta U, change in potential energy. Potential energy, write down the formula. Work by internal and conservative force. It is defined for conservative. What is conservative, not conservative? Work.
Sir, is that a minus symbol?
Minus of this formula, direct formula. Okay.
Okay.
Formula. For example, this is our Earth. This is the Earth. And one block is placed. Clear? Having mass at center of the Earth. If you are raising this block up to this height, you are raising this block up to this height, and this height is from the surface of the Earth, how much? H. This is the reference. From here, your potential energy is U1. Okay? Reference line.
Okay.
I will tell how to apply. Reference line. And here system is two particle system, Earth and block. This is our system. Okay.
Okay.
Then gravity will be internal force. Here on this block, gravity will be like this, mg. And it is internal. Okay. Because it is internal to the system, within the system. That's why it is internal. And mg, already I have told. Gravitation force, I will explain. It is conservative force. Okay. Then how much work by the gravity? Force into displacement, constant force. So we can apply force, displacement, angle is 180. Okay. This is initial.
Sir, can you please repeat it again?
This is initial, na? This is final. Displacement direction will be like this. Okay.
Okay.
And it is a magnitude is h. Force is mg down. So angle is 180. So work done by gravity will be force is mg, displacement is h, cos 180 minus. So how much work is done by gravity? Minus mg.
minus mgh.
This is the work done by the gravity. If somebody is asking like, what is the change in potential energy when you are taking this block from A to B? So you will write delta U will be from A to B minus of work done by internal and conservative force, that is minus mgh. Okay.
Okay, sir.
Then final change, always we are calculating final minus initial. Final is UP minus U, that is mgh. So we can find only change. But if you want to calculate the UB, then you need to assume UA to be 0. Okay.
Okay,
Then
sir.
UB will be, this is what you have learned in NCERT. Okay. Direct formula they are giving plus mgh minus mgh, but you should understand the meaning. Okay.
Okay, sir.
But if the same block is going from B to A, then it will be minus mgh. Okay.
Okay.
So now onwards, like no need to mug up, no need to write the formula. This is a reference line. Okay.
Okay, sir.
Reference line. If you are going up, plus h. If you are going down, minus h. U plus mgh. Here you will be minus mgh. Okay.
Okay.
Is it clear to you? After that,
Yes,
write
sir.
down conservative force. Okay. Conservative force. First, write the definition. Okay. What is the meaning of this?
Sir, conservative force, sir.
Conservative force. Write down. It is a force. First, write down. It is a
Oh,
force. Force round the trip whose work round the trip is 0. Round the trip is 0. First point. Okay.
okay, sir.
Second point. It is a force. These are the points of conservative. Okay. It is a force whose work does not depend on path. Does not depend on the third point. It is a force which does not produce heat. Okay.
Okay, sir.
Next, it is a force which does not does not depend on velocity. Okay.
Okay, sir.
Next, it is a
Sir,
force. Velocity means velocity. Even if you are taking the object very fast, slow, initial final should be same. Okay.
okay.
It is a force whose work depends initial and final position. Initial and final position. Okay.
Okay.
Example of these force. Write on example. What are the example? Conservative force, like spring force. Okay. Gravitational potential energy. Gravitation force, you can say. Okay. This is the
Okay.
conservative force. Directly you should know. Next, spring force is conservative force. Electrostatic force. In class 12, you will learn is also
Okay.
conservative force. Electrostatic force. These are the example of conservative force. Opposite to that, okay. Opposite to that, there is a
Okay.
non-conservative force. If somebody is asking, opposite to just reverse of this. Example of non-conservative force. Write down. Non-conservative force. Write down. Friction. Friction force.
Okay.
Next, magnetic force. Third, induced electric field.
Sir, induced electric field means what, sir?
In class 12, you will learn. No need to mug up. I just told.
Okay.
Okay. So
Okay.
gravitational potential energy just now I told. In the similar way, you can find the elastic potential energy. Okay.
Okay.
For example, direct actually. I'm telling elastic potential energy. Elastic potential energy. Potential energy. Meaning is I will explain. See, if I take one block, this is the clear. One string is here.
Yes.
This is the block M. Initially, it is in natural length. Okay,
Okay.
natural length. We just extend this spring by applying a force like this. So how much displacement from here? X. Clear? Now, you please tell me, torque done by spring. If a spring you are going to elongate, then a spring force will be back. Okay.
Okay.
This spring force already have told it is opposite to the displacement. Then how much work is done by the spring force? It is, see, the spring force value is minus kx. If you increase x, then this is also vary. It is also increasing. So it is a variable force problem. Okay. Forces, spring force is
Okay.
variable. Here, our spring force is variable. So we can't use W is equal to F dot S. We will apply small work done. For example, you are elongating the spring for a small displacement, like for dx. Okay, how much?
Uh,
Dx. Okay, this is you can final displacement. Okay, x1.
Sir, can you please repeat it like dx? Can you please repeat it?
I'm saying that spring force vary with x. If you increase x, spring force will also vary.
Yes,
Here,
sir.
so spring force is variable force. So we can't apply W is equal to F dot S. This formula is valid when
Okay, sir.
force is constant. Okay,
Okay,
we
sir.
can't apply. So we will use this formula. W is equal to integral F dot ds. For applying this, I just consider we extend. We are extending this spring for a small displacement dx.
Okay.
Dx is small displacement. For this small displacement, our spring force is almost constant. It will not vary much. That's why we are taking a small displacement. Okay.
Okay.
Now in this small displacement, you are doing work, small work done. dw. Clear?
Okay.
That will be spring force F dot dx, and the angle between these two will be what? 180 degree. So can I write like this? Ax dx. Okay.
Okay, sir.
So dw will be minus kx dx. Now you will do the integration. Okay. Initially, what is the extension? X is 0. Initially, here now there is no extension.
Yes, sir.
For x1, w. Okay.
Okay, sir.
Yes. So if you
Yes,
calculate
sir.
minus k x dx x square by 2, 0 to x1. So it will be minus k x1 square by 2. This is the work done by the spring. It will be w. Okay.
Okay.
Lower to higher, na lower limit, upper limit we are putting like this. So finally you are getting how much w work done by the spring
Minus
force minus half
kx square by 2.
kx1 square. What is x1? X1 is, you can write, x1 is final extension, or x1 is final displacement, or final extension, or compression. Okay, maybe
Okay.
compression, it may be extension, final extension or compression. But remember, this formula is valid when I consider when I consider initial spring at natural length. Okay, initially
Okay.
spring is in its one minute. One minute. Clear? Initially, spring is in its natural length. Okay.
Okay, sir.
Actually, one boy joined. He is a different person. His class is offered, but he by mistake is joined. Okay. Initially, spring in its
Okay.
natural length. You should apply this formula only when the spring in its natural length. But my question is, if you are extending the spring when it is not in natural length, for example, like this. Initially, natural length, you extend
Okay, sir.
up to this x1. Initial deformation, you can take xi. Again, you deform. Question may be like this, na? X
Okay.
final. How much work from here to here? Question may be like this, na? Question also be, na?
Sir, then how can we check, sir?
Then direct formula I am telling you. This formula WSP is equal to minus half kx1 square. It is valid only when the spring in its natural length initially. Okay.
Okay.
Now this formula I am telling, this is valid for every case. W will be, you can write, it is minus half k x1 square or x1 square minus x2 square. x2 is final, x1 is initial.
Okay.
Okay. So
Okay.
x1 is initial deformation. Okay. Extension or deformation for x2 will be final. Okay.
Okay.
Is it clear?
Yes, sir.
Actually, fan is not working. That's why it is happening. So if they are asking like this is the work done by the spring. X1, x2, you understand? What is x1, x2? Like
Yes,
x1
sir.
is 2 centimeter, x2 is 4 centimeter. And how much work from 2 to 4? Apply the formula. Work done by the spring force will be minus half k x1 is 2 to the square. Convert it in meter. Okay, I just explained like this.
Okay.
Okay, x1 is initial extension, x2 is final extension. Clear?
Okay, sir.
Okay. But if they are asking like
Okay.
1 minute actually, page finish. I'm adding some more minutes. Good. Okay. So direct like
Okay.
okay. Mhm. Hmm. So what is the work done by the spring force? If you want to write delta U. If somebody is asking what is the spring energy, gravitation, not gravitation, potential energy is stored in the spring. That is minus of work done by spring force. So definition now. So how much work is done by the
Okay.
spring force? Minus half k x1 square minus x2 square. So u2 minus u1 will be half k. What is the answer? It is minus now. What? How much work is done? It is plus. Okay. This what not? I told. See right here plus. Okay.
Okay.
If I write here, I have written correctly. Okay.
Okay.
So it will be when you take minus it will be x2 square minus x1 square. So very very. This is the potential energy formula for a spring. Okay.
Okay.
If delta U is U2 minus U1. One means if initially x1 is 0. If initially x1 is 0 means natural length means mean position. No extension. Okay. We say
Okay.
mean position. Okay. That at that condition, if you are extending from the initial conditions, it will be 0. Mean position U1 is 0. Assume. Then it will be half k. X2 is x square. Let us suppose x. So it will be, this is what you have done. U2 will be half kx square. Okay.
Okay.
Any doubt?
No, sir.
Clear? So formula is half k x2 square minus x1 square. This formula is very important. You should mug up or remember this. Many questions are coming. Delta U will be for a spring half k final x2 square final extension minus initial extension.
Okay.
And U2 means at final. U1 means at initial. Okay?
Okay, sir.
Any doubt?
No, sir.
This formula is valid for both extended or compressed. Even you are compressed now. This is valid for both cases. So this is
Okay.
valid for both
Extend.
extended spring and compressed spring. Okay?
Okay.
Compress spring. Clear? I will share you
Okay.
one more meeting link. You just join from there. Okay?
Okay.